Augmenter in general as a company is specializing in augmented reality, which is tonight's topic, and also a little bit about virtual reality, two similar technologies that have different implementations, but there's a lot of commonality underneath the surface. So our backgrounds have been in the DoD space predominantly. Personally, my degrees are in physics, specializing in optics, and I spent 14, 15 years doing high altitude airborne surveillance systems. Alex has a degree in computer science and worked on a graduate certificate in systems engineering. And a lot of what we're seeing here is really the benefits of systems engineering, how you can integrate diverse sort of products and hardwares together to help push things forward in a novel sort of fashion. So we see that there are a lot of possible market verticals or different applications in industry or in government that can use this sort of technology, particularly in the AR space, and that's what we'll be focusing on tonight. So our emphasis, well, I guess let me back up. When you look at the AR space as a whole, there are 4 different main sort of areas where there are activities possible or benefits that can be realized. And if you look on the 2 on the right, which is kind of a hands-free operation for production, for doing workflow or improving assembly processes, things like that, is kind of one common use. Another one is for remote interaction or field support, where you've got your highly trained engineer kind of works out of the office hub, and a series of technician types may go out to the field to support different sorts of installations, be they border cameras or expensive machines or whatever. Then they can actually talk back, if you will, to the subject matter expert back at the plant using essentially a telepresence, where the person can provide some augmented guidance of, no, cut the blue wire, or something bad will happen. So there's a lot of activity in that space, and if you read a lot of the trade journals, you'll see a number of different startups that have gotten funding or advancing products in that space. So when Alex and I came along, we said, that's cool, that's interesting, we can certainly do that, we can consult in that area, and we can assist in that area, but our particular personal strengths is in the area of highly integrated video systems, of precision timing, of larger systems integration sort of work, visualizing 3D data as an example, which we'll be showing you an example here later tonight. So that's really what we've been focusing on. All of our products kind of share that as a core competency and a core capability. Alex has developed a geo-registration capability that's embedded inside this Microsoft HoloLens, and there'll be a demo in a little bit on that. And with that, we've really been kind of pushing the limits of what you can do with an untethered AR kind of out in the real world, where this particular device and some of the other devices are designed to work in an indoor application, lots of vertical walls. I get lots of nice registration capabilities. Well, with the software that's in here, we can actually go walk out in the parking lot, and we can tell you more or less where you are in terms of latitude, longitude, and altitude. And that allows us to access a totally different sort of data sets than you could do just with indoor camera-based sort of registration. We've also, like I mentioned in the beginning, and this is really going to be kind of the end of what I say about it, have taken kind of the same approach in terms of some cutting-edge VR capabilities. One of them, if you see the yellow-looking thing on the right, is actually a test chamber for the U.S. Air Force, where they're looking at integrating 100+ sort of cameras and delivering that real time into a virtual reality space. So we've actually written a proposal for that. We're waiting to hear on that, but that ties in again to the systems integration, the precision timing of video, the precision alignment, things of that nature. Okay, so I've said augmented reality, I've said virtual reality, and as Alex mentioned earlier, that means a lot to us. It might not mean quite the same to everybody, so I'll just do a quick sort of definition. AR, which is kind of the way I refer to it, allows the digital insertion of a live virtual image, pretend image, that the operator can see overlaid across the real world, so that I would actually be looking at the room, I'd be seeing everybody, but there'd be a dinosaur or whatever floating right there. And to me, as the wearer with the headset on, That is a perfectly legitimate and real sort of object, but it's invisible to the rest of the room. Now, the real advantage is that allows you to move around. It allows you to build your turbine or do whatever you're doing and still experience the world around you. VR, which you see the headset there on the right, the gentleman on the bottom right corner, is a fully immersive sort of experience where you've got the computer screens of the displays are inside an opaque headset that creates a virtual world. It might be a representation of the room around you, or it might be the surface of the moon. It doesn't really matter. Wherever the experienced designer wants to place the wearer, they're immersed in this environment. And from a computer processing standpoint, that's more limiting. You usually need a fairly high-end computer to deal with that. You're tethered to some sort of off-board graphics processor. You may need to have some sort of external sensing device to know where you are in that virtual space, where the AR devices don't have that sort of limitation. Now, there is a tremendous amount of activity going on in the hardware space, particularly in the area of AR right now. It's blossoming, it's growing crazy. We'll talk about some of those, and actually some of the things that we talked about less than a year ago are already extinct, and projects have been shut down. So there is a lot of churn in this space, and it's quite interesting.
What is DoD again?
Department of Defense. See, there you go. Stuff that we toss out. So, as I mentioned earlier, that's been kind of our background. I was working at some of the large government contractors, and so we've supported the different branches of the government. So there are multiple implementations for AR. I'm sure probably everybody in the room, or almost everybody except for my firstborn, who really wants one, has their own smartphone. And with those, there was the big craze about a year ago or so, year and a half ago, for Pokemon Go. That's when kind of the broad populace said, hey, look, it's AR. There's a little creature right there. This is so cool. So that is one implementation, and there is a lot of work in that space. There's a lot of reasonable commercial applications for marketing purposes, or how big is this couch that you're looking at in IKEA or whatever. And so you'll see a lot of discussion about that just kind of in the general market space. As you start moving up in terms of the performance capability, yes, you're moving up in terms of price, but you get more for your money. You've got some fairly simplistic display glasses, which is a headset, but it doesn't do the precision registration. Once you start having a tethered headset, something like the Meta 2, you've got a very strong capability, but you're plugged into the computer over here. But it's got a nice wide field of view and a lot of capability at your fingertips, because that computer, the host computer, is still doing the video processing. But really kind of the holy grail, the thing that we've put the big gold star on, that everybody's waiting for and still waiting for, is the true untethered AR headset. The Microsoft HoloLens today is the most capable of those that we're aware of. There continue to be lots of press releases about Magic Leap and some of the other products that are coming online, but their capability hasn't really been proven yet. So, touching on the mobile device AR for just a minute, I mentioned Pokemon Go. It's a fairly simplistic application. You kind of take a video feed from your camera and you smash a little critter out there, and it's not particularly registered. It doesn't do a lot of environmental sensing. It's a fairly simplistic form of programming. They recently did a release using ARKit and most likely AR Core, I suspect, to take use of some of the co-processing capability that's being rolled out into some of the higher end phones. And mentioning ARKit, came out last fall. Apple, you can't get out of the way of Apple. They're everywhere. There's 200 million of these things. And with the ARKit capability, it can do a basic scan of the environment and find level surfaces. It could find that table right there as an example. And with that, you can do a much better registration than the Gen 1 Pokemon Go, where there's this thing. Oh, there's now an object. My thing should be here. Yes, sir? That means that you recognize where something is in space, and then you tie your digital object to that. So as I would walk around, if I were the phone, I would say, hey, this is that same surface, so I'm going to keep my digital object here. as I move around because I have registered that location in space.
So if you're looking at your phone, you know, your little creature or whatever it is, will stay there. You know, it's not just like it's like, you know, on your screen. It knows where it is in space. So it makes it seem convincing to you. Otherwise, it's like, well, no, I put it, you know, I put it on the chair, and I look over here, and now it's some other place.
Right. So
it sticks where you want it to stick.
an unregistered example would be, okay, that table is 6 feet in front of me, okay? Well, if I move over here, so it's 9 feet in front of me, a registered image is still going to be on the table instead of floating off in space 6 feet in front of me, you know, not tied to the physical location. And you know, there's a lot of processing capability in today's, you know, tablets and mobile phones and things like that, and they can do calculations of that nature in a fairly straightforward fashion. When we talked and gave this presentation back in August, you know, Google had this Tango platform, was kind of their version of AR, and the Tango system was basically tied to one particular type of camera that was being installed in different phones. So if you had a Tango capable phone, good for you. Well, not everybody did, and of course, you know, you spend money for a phone, you want it to work for, you know, 4 or 5 years or whatever to get your money out of it, and so that kind of wasn't the best business model. So they actually shut it down. It concluded just last month in March of 2018. They announced this about 6 months ago, but it just shut down in March and has been replaced by a new program called AR Core, which is more generic, but kind of one of the challenges when you work with Androids is it is essentially an open ecosystem in terms of the hardware combinations, where Apple is a closed ecosystem. Apple knows exactly what they've made. They know everything about it. You got a Samsung. Oh, I got a X, Y, or Z, and it's an Android device. So that, you know, it's lagging behind kind of the AR kit because of that ecosystem openness. So we've updated this from the last presentation. There are a large number of wearable devices that are available on the market today. And this is kind of a comparison. I mean, Alex and I are both kind of picky. And I'll kind of briefly go over the color code. It's the grays are just kind of like you'd see in your check register, you know, a dark line, a white line, so that you can kind of break them apart. So don't pay any attention to the grays. Something that is red, you know, to us is just too limiting for a practical sort of real world application like we're trying to do. That does not mean at all that it's not very valuable in something like an enterprise setting, for a person on an assembly line or doing quality inspections or things like that. Things like, you know, the Google Glass with one eye. There are certain things and applications that is perfectly valid, and the price point is right. That's great. With our focus of trying to do some open world, you know, immersive sort of AR, that didn't really fit our standards, was hence, in this particular example, why it got a red grade. The yellow is kind of middle of the road. In some cases, you know, here's the HoloLens, you know, it's on top line. It's a little heavy. We'd like it to be lighter than that. You don't want to wear it all day long at 20 ounces. You know, you got some issues with battery life when things are self-contained versus a side pack where you can change the battery, things like that. And also price, kind of the $1,000 to $1,500 is kind of the magic price point. You want something like this to be just beyond like an Apple, you know, top-end Apple phone or whatever. And a lot of them are not there yet. But, you know, many of these devices have some good capabilities. We're particularly partial to the HoloLens because of the quality of the experience it gives the wearer in terms of very precise registered holograms, and we'll show you some of those here in a few minutes. So we like that. There is what they're calling Gen 3. Microsoft actually skipped Gen 2. They were going to release a second generation of this, but we're happy enough with the developer version that they passed over that. They're working on Gen 3 right now. It's supposed to come out sometime later this year to early 2019 is what we're hearing. One of the big things is that the rumor mill says it's going to have almost double the field of view, if not a little better. That's going to be, you know, that's really the drawback of this, is that its field of view is fairly limited. And if they can double that, that'll be a substantial experience improvement. But in terms of the time of flight sensors, the gyro, things like that, as long as that baseline carries forward, it's going to be a very solid unit. Magic Leap, there's been a lot of hubbub in the space about Magic Leap. It's a $2.3 billion startup that nobody knows exactly what they do, and they won't talk to you unless you have an NDA and. They claim they started to ship some units. You know?
I actually heard from a couple people who say they have.
Oh,
Units.
okay. So there you go. They have units, so that's good.
Safe. That's right. You have to buy a safe.
Oh, that's right. You had to buy a safe and put it away. You know, the development environment is very favorable. It kind of needs to be out in the community, out in the wild, if you will, to get some real feedback for how good are the cameras, how good is the registration. You know, we've played with some of the other brands of equipment, one of which is actually not on here. It's been since retired. But we tried it less than a year ago. You wear this nice, beautiful $10,000 plus headset, and it's going to be awesome. And everything's janky and moves around. And you know, that sort of experience, forget the price point, that just, it's unnerving as a human, right? You'll get seasick wearing the thing, and you don't want that. So a lot of good information here. Happy to bring this back up if people want to look at it for comparisons later or whatever, but trying to move on here. The HoloLens, like I mentioned, is really our unit of choice at the moment. It's kind of the first and most widely available freestanding AR headset on the market at this point. It's being shipped now for 2 years. Started to developers only. Of course, you can now buy it commercially. It's a little more expensive. This is one of the developer editions here. It's got a mobile grade processor and some onboard graphics, some really fancy displays capabilities. But the beautiful thing is it is entirely self-contained. We've got it set up here as a spectator rig so we can actually show you some videos up on the screen here in a little bit. But normally you just put it on your head and off you go. You don't have to do anything until it's time to recharge your battery.
And all we're doing with that thing is plug it in so the battery gets run down. That's all
Right.
it's plugged in is power.
And so you'll see more about that. Magic Leap, I already mentioned them. They've got a ton of money. I don't know how they did it. I'm really curious to see where that goes. It has, you know, I've got to believe it's got a lot of potential. So we'll see how that all comes together when it comes out. One of the interesting things that came to light last week is actually an open source AR headset, and it's by Leap Motion. They're calling it Project North Star. They're kind of teasing the unveiling here. We're excited about it. We may well build one for an application, but, and this is the big asterisk, is it's not a complete system. Yeah, they want you to use their hand tracking software and this and that and the other, but you still got to bring it all together. You still got to decide what your application is. You got to ruggedize it. You got to get its optics fabbed and things like that. And that doesn't necessarily scare us, but it might just live in a fancy display on the desk, and you know, we'll see what happens with that. But it's really interesting to think about them actually open sourcing some of this. I mean, that's kind of the new way of things. There's a lot of you know, sharing forums, of course, for some of the AR algorithms and things like this. So it'd be interesting to see where this really goes. And as we labeled over here, and this is straight off their release, right? Oh, great, let's go have some, you know, electrical coatings that we can make it nice and dim when you go outside and things like that. That's really awesome, but that's also really hard, particularly at a systems engineering level when you start putting it all together. So yeah, we'll see. It's a big space though. There is a tremendous amount of investment going on in this area just as a technology as a whole, fundamentally because between batteries becoming very capable and processors getting nice and small and efficient, you can kind of put those things together and do a lot in a small package. There's been a tremendous amount of money by a number of big players put into this space. I mean, you know, $2 billion plus. Microsoft has about $2 billion into this from what we've heard. You know, Magic Leap, you know, 2.3 billion was the last count. It's coming. It's just too big not to get here sooner or later. The real question and the title of the pitch is, are we there yet? It's very new, is our opinion. You can see on the hype cycle here, we're right kind of at that trough of disillusionment, kind of starting to climb out. Vanna will go up here and point it out.
Yeah, it's augmented reality is right here.
Yep.
So this is the, right here, this is the smart workspace or the 4D printing. I'm not sure what 4D printing is, but it's all the way down here on the,
just
yeah,
in
it's
time.
going to happen yet. This is where everyone gets hyped up and says, oh, it's going to happen. Then you realize, oh, it's not there yet. And then once you get down what they call the trough of disillusionment, then you start climbing back up to the, oh, we can actually really do something with it now. And so AR is just climbing out of this. You all remember Google Glass from a few years ago, where Google Glass is going to revolutionize everything. Never realized, like, oh, this is kind of weird and small, and no one's really happy with it. So then everyone, oh, AR is dead. But no, we're climbing back out. We're actually making a useful product
And
with AR now.
right, and the interesting thing to note is the dot next to it, farther, climbing out into the world of enlightenment, is actual virtual reality. From a hardware standpoint and from a ecosystem standpoint, VR is about 5 years ahead of AR. As evidenced, to us being, the former government contractor guys, is looking at the solicitations we see from the government. Why are they finally saying, look, I can actually, do this 3D visualization in VR. It's becoming a useful tool. There's a lot of training tools, a lot of things like that are being driven there. And it won't be too long until AR is behind it. We did attend, and I'm not trying to have this be a big government sort of pitch, but we did attend an industry day earlier this year, and augmented reality is one of the top 3 technology research areas for the Army. There's a lot of effort going into that space, but it still has a little ways to go. But as this really comes to life, the market is much, much larger for AR, 4 times, 5 times larger. It's much more practical because you're not isolated. It's an open sort of experience. But that really does have some social challenges. And I'll let Alex take over from here. How's that?
Good.
I will socially remove my talkie thing, if I can find it. Did I get it right? There we go. All this is on tape. Hi. See? Wardrobe malfunction. Have fun.
Okay, back pocket,
Back pocket, check. What happens when you have people that don't have back pockets?
belt.
Belt. What if they don't wear, what if they're wearing like sweatpants or something?
It could get interesting. Up through the shirt.
Pardon me. That's right.
There you go.
little please wait, technical malfunction sort of thing going on. Check. We're good?
I don't know yet.
Good?
Are you gonna stand there?
No, I'm going to stand back over here. All right.
Hold on, let me get a focus.
Focus, focus, focus.
Okay.
All right. So we're talking about AR and wearable AR. You guys can see the size of this. You can come look at it later. But it's kind of a bulky thing. And one thing that happened with Google Glass is everyone was putting these on their head, and they all started worrying about what they were calling glass holes, who were basically going to walk around and tape everybody all the time. So that was kind of the first real sort of implication of people don't really like you filming them usually. If you were walking around with a camera in just public and just filming people like this, everyone would get kind of weirded out by that for probably really good reasons. So there's a whole sort of social acceptance to some of these AR headsets. You're wearing a computer on your head. People don't know what they're doing, and it's not quite there yet. Companies, a lot of companies will basically say, you can't take your camera in, or they try to say that even though everyone is carrying a camera in their pocket, but they'll tell you that you can't have a camera in the workspace. And AR wearables are going to have the same sort of problems that mobile phones have. Everyone's brings their mobile phones into work and plugs them into their computers and uses their phones for email. Companies can get kind of weirded out about the information they're passing around. Where Leif and I came from, the big defense companies are really, really terrified about that for obvious reasons, about people trying to steal all the things. But any company is going to have a problem if they have really proprietary information on your head walking around. And so the question is how do you how do you use these things in the workspace? And quite frankly, beyond that, this thing's still really bulky. How do you put it on your head and use it without looking like a total idiot? You know, walking around in public, you know, people with Bluetooth headsets, you'll see them walking around, you know, the airport or what have you, just wandering and waving their arms around. It's going to get nothing but worse, because now people are going to be able to have, you know, goggles on their head and, you know, be chasing Pokemon around the airport, and you will have no idea what they're doing. So that's kind of a social challenge, and that we all are going to have to experience as we go forward, because it's really kind of a new thing. So when you're writing software for it, there is a huge amount of stuff that has to be considered, because there's a lot of, these things are very different from when you're using a computer or a phone or anything like that. It's a very different sort of way to use it, because you're not looking at a screen, you don't have a keyboard, you don't have to, you're not sitting at a desk. You've got to basically constantly think about the new ways for people to really experience and use their devices and interact with the software that you've written with the environment. If you could do it on a computer, that's one thing. But if if I had a hologram on the table and I was kind of like, you know, doing this in real life, and you guys are all looking at me like I'm crazy because I'm just, you know, just kind of moving around like here. How do you use that? And how do you bring that experience out? How do you interact with people who aren't wearing the headsets? A whole bunch of system considerations for the interaction that you have when you're developing the software. And that doesn't even get into the fact that the hardware itself, you know, it's very different. It's not like a little screen. You've got to be able to see through it. You've got to see how well it's tracking. How do you interface with it? You don't have a keyboard. You don't have a mouse. But you've got speech. You've got your hand movement. What do you do with it? So all kinds of things to consider as you go forward, you know, working with AR. What we have down here is the different devices that were supposed to come out this year or were coming out. We made this chart last year, and we've already marked one of them as late. This ODG glasses, which look really nice on paper, were supposed to come out in third quarter or fourth quarter 2018, and there's nowhere in sight. This giant headset, which looks like it makes you look like a stormtrooper or someone out of Spaceballs, is what I was thinking. They announced it cost $15,000, and everyone went, well, I'm not paying that. So it just died right there. And so there's all these people who have been providing these new types of hardware, but it's really hard to make good hardware in this space. So it's to a certain extent it's been lagging a little bit what the optimistic projections of these companies are, because it's really, really hard. It's kind of a whole new level of development and hardware needed to make a good experience. And so the skills. So there's a lot of things that when you're developing for AR and VR, AR and VR can be very, very similar in these regards. The first major thing is that when you're writing software for these, if you want to do what I would call a really interesting application, where you're actually using a spatial orientation of the thing in the workspace in the area, you're inherently already in 3D. So you pretty much got to use a 3D engine, which is basically a 3D game engine, because that's pretty much what people have. You can't take a 2D JavaScript program, no offense to anyone who writes JavaScript, but you can't take a 2D JavaScript program and slap a couple buttons on there and have anything that's a really interesting, usable AR application, because you're kind of missing that whole third dimension and the moving around in space. So you've got to basically learn how to use a 3D graphics engine. To program that, you've got to use C# if you're using Unity, which is one of the major engines that's out there, or C++ if you're using the Unreal Engine. If you want to make assets for it, you've got to use 3D graphics programs like Blender, Maya, 3D Studio Max, something which lets you make a 3D model in space. I am a terrible artist, but I can still draw stuff in Paint.net, and look at me, I can draw a picture and I can put that into the application. I tried making a 3D model and it was terrible. It was the word, it didn't match what I was trying to do, and it's a whole new level of complication to do that. You've got to learn how to program your device, your software, the shaders to look good. You've got to learn how to light your scenes so that your items look like they naturally fit in your scene. And then on top of all that, you've got to make sure this thing runs properly, because you don't have a giant computer up behind you with an untethered headset. You've got in this case, a top-of-the-line mobile processor from 2014. It's like a 1 gigahertz processor. It doesn't do very much.
So you've got to make sure your performance is good, because if you don't get your performance right, it can honestly make you sick. Because what will happen is if you're looking around and you're trying to look at a scene in VR and you move your head this way and it doesn't move or kind of lags behind it, and this is more prevalent in VR than it is in AR, but if you're seeing and your whole experience lags, your mind will tell you that you've been poisoned and start making you go, okay, you better start throwing up now, because that's what the brain's response is if it cannot match your visual cues to your ear cues. So it's not just oh no, my software's slow. Your software's slow, and it could make some of your users throw up, which is probably not a good impression to have on them. Now the nice thing is that after you've gotten all this stuff figured out, it applies pretty much to the entire range of devices. There's the Unity, for example, can target VR headsets, the Google Cardboard, HoloLens, everything, just with one common platform. And so your skills are very transferable between those different devices. But it's a very different sort of skill set than what's historically been used. The user interference, or user experience. What you see on, like Pokemon Go, the mobile experience, what you'll see is you have a video, you're holding your phone up, and you're moving there, and you'll have a video scene, you can still poke at it. It's still a very kind of conventional interface. You've got video, but you have your 2D sort of buttons and widgets and all the things in front of it. When you go to an untethered headset, it doesn't work anymore. You can't put things in front of you that are locked to your head, because what Microsoft research has shown is that you will get people sick, because you move your head, you expect things to move with it. So you expect to have your user interface kind of in space, not necessarily in a flat plane, but you've got to have it around the world and around the thing you're trying to interact with. So you've got to really kind of figure out how you're going to interact with things in a spatial sense, while at the same time realizing you don't have a keyboard or a mouse. So you've got to start using things like speech. You've got to use things like where the guy is looking. You've got to use hand gestures, things like that, to determine, so the guy can, or the operator using it, so the user can interact with their environment in a much more natural sense than they ever could with the computer. So everything you've got has got to kind of consider that 3D space and how you deal with that. One thing we did, so this is a kind of recent thing that we've been working on, is we took a bunch of data from the U.S. Geological Service, some elevation data, some heights. We took some streets and the like from OpenStreetMap, where you can see the things, and we put them together. And we went down to Auburn, drove down to Ashford Park, mainly because I knew it, been there before with my kids, and we had some nice altitude data. And it's right here. Yeah. So this is what it looks like when we're looking on the table. So this is what we see when we're in the HoloLens. So this is our office. We made a nice little elevation map, and so this is a small-scale version of Ashford Park. You can see the heights. You can see all the power poles. You can see the Highway 80 going by there, and we just placed it on the table and walked around it.
So talk about the elevation data versus the vector.
Yeah, and so what you'll see. Let me go back a little bit. There's two pieces of data here. That gray in the background is the actual heights. The USGS actually makes available on the internet really detailed elevation maps for the entire country. So we took that data, we took the data from OpenStreetMap, and we, on the fly, ran that in the HoloLens, such that you could easily walk around and see what was going on the table. Then we went to the park, and we ran the software with our geo-registration items, and we were able to basically line up all this altitude data with all the poles and streets and things like that. So you were wearing this headset right now, and so this is what Leif was seeing outside his headset. He could see how all the hills were going. He could see where the park label was, where all the power poles. Well, so what this system does, so what the HoloLens does, is as you're moving around, it will store a constant spatial map about where you are. So at this point, it's got this entire area all mapped. I can walk around the entire office and goes, I know where you are. So if I put down a dinosaur right here, I can always come back and look and see the dinosaur. hanging out in in the room here. What we went down to Ashford Park. What this device does not have is it doesn't have a GPS. And I was like, oh my gosh, why doesn't it have a GPS? And the reason why is because a GPS is not accurate enough for any sort of position like this. GPS is, the phones, honestly, you pull your phone up and it gives you a little map, a little blinking dot, it's lying to you. It's using a bunch of different things, but actual GPS is, meters, 3-4 meters or something like that. And if normally that's fine. Okay, you're gonna go driving your car, driving the road, tells you where it is. When you're doing something like this, where you're actually looking at it, 4 meters is gonna go, well, if it's like, oh wait, you're over there. That's not going to help anybody when it comes to the positioning of the system. So what we did is we tied in the spatial mapping of this with the USGS and other data to allow a really kind of real-time, calibrated view of where you are. So we're relying on HoloLens for some things, and we're relying on our previously done data for other ones. I'll show you a demo of this one pretty soon. Well, the other thing we do is because this is a whole mobile device with connection to the internet, we did a whole sort of software where we're showing real-time airplanes. I'll just show you the video because it's kind of more interesting. So this is walking around out in the little area over there. This is Vegas, and as we're walking around, we put this map in place, and we're seeing all the airplanes flying around Vegas. So we can look at, so this is all the traffic. We just have the altitude maps and the terrain. And we can click on an airplane, and it'll tell us exactly, it gives a picture of what the airplane is. We're pulling that from another source on the internet. So this is the actual, when we took this, the live position of the aircraft over where it actually is in space, so you can really see where the traffic is. Vegas is a good example because they have all these helicopter tours, which go flying down Vegas. So you can sit there and you see these little helicopters all following a nice little path right down the strip. This whole model was created by one of our partners. What they did is they basically flew an aircraft, got a whole laser ranging map of the area, a whole very detailed elevation map, and they classified it and drew all these different buildings. And then we took it all and imported it all into, and are on the fly generating this entire airport map, all of the geometry, and bringing in the airplanes live. So as I move this thing around, you can see, this is where the airplanes are coming in. This is the airport. And what our customer is looking to do is basically be able to manage a airport and basically understand where all their vehicles are on the airport. There's how many vehicles on the airport what are they saying? There's thousands and thousands of vehicles. They want to know where they are. So if you can basically have two different views, one guy is sitting there looking at his airport on a blank table, but he can see all this stuff, as well as the guy who's actually on the airport, kind of in a one-to-one view, able to find things on the airport. What we're getting is there's what they call an ADS-B transponder from aircraft, where they're always broadcasting their position, and this is when they're getting updates on this. We actually looked earlier today to realize that the coverage around this airport was actually terrifyingly low. So you're seeing, the public data that we're pulling is got a little bit of jumps in it. So we're going to talk to our friends and have them put a receiver down there to get better data on there. But that's what you're seeing the aircraft kind of come in, and they're jumping because we're not getting the hit rates at the level that we need to.
That's live ADS.
Well, yeah. So good example. So the guys that we're talking to, they do airport management. There are many lights at an airport, and the lights break a lot, because when they're lights, so they get damaged. And so when you say, hey, go fix that light, how do you know which light which one that is again? And so you put this thing on, you drive out there in your truck, and it'll tell you it's that light right there. You aren't trying to do this, look at the map, look up, down, look, you're not doing that. You've got the information right in front of you, right in front of your face. Yeah, the fact you've got this information in 3D, and this is one thing that Leif and I, there's lots of ideas, it's like, and we always come up with ideas, when is a 3D view of things better than a 2D view? Because quite frankly, 2D views are pretty simple. Everyone kind of knows, it's like everyone knows how to do a map. But in a place like this, we got airplanes, 3D becomes really, really useful, because then all of a sudden you can just visualize, like in that other video, Bert was seeing it himself, he's seen all the airplanes, the high ones, the low ones. You don't have to look at the number, look at the flight level, then go, oh wait, he's below that guy. You can just see it. It really becomes an advantage for visualization. And quite frankly, one of the barriers to entry, the primary barrier to entry when it comes to that sort of stuff is, do you have all your information already, in an electronic format? So, if you've got it all on paper, well, yeah, I'm going to put it in AR, but I don't even have it in a computer. It's going to take a little while for me to get it into AR or anything that I can do it. So there's a whole bunch of steps that have to be done. I think it was a Lockheed who makes a C-130. Yeah.
No, please.
Yeah. Yeah. So Lockheed makes a C-130, and someone's said, "Oh man, we can use AR to help build your C-130s." And I think some engineer says, like, "Do you know how much paper we have in this thing? It costs more money to design a new airplane than it would to take everything we have in paper and put it into the computer. So why don't you come back in about 20 years?" Sort of stuff like that. It depends on the industry, how electronic there is already. Or tribal knowledge. If you don't have this stuff documented at all, it's all just in a couple of guys' head. Well, AR ain't going to help you there. Some of them are basically Android phones with a web browser, and where things were black, it's clear. You can see through it. So you can just basically fire it up, in a web browser, and whatever you can display on an Android thing, you can put in front of your face. There are a lot of the what I probably call the 2D ones. I think are going to kind of a web browser-based sort of thing. So anything in a web page can be displayed in front of you. It's pretty flexible in that from a 2D overlay perspective, and it's all just kind of scaling and sizing and making sure it doesn't get in the way of what you're looking at.
And I intended to.
Yeah. So if you use Unity these days, that's a 3D engine. What it has built into it is they've got the Vuforia marker tracking built into it. So you basically can print out a little target, and it will locate that in the 3D scene. It knows the size, so it can accurately place that thing. I haven't done any testing to figure out exactly kind of how, what exactly is that accuracy that's in there, and how accurate, this thing will operate by itself natively. This is a little laggy, and my camera calibration is not as perfect as I'd want it to be. But when you're using the thing, you can kind of see how well it tracks, and I think it's really depends on what you're trying to do. And that kind of rolls back to the specs.
So they're developing or have developed LiDAR on a chip.
Yeah.
So that could be applied to this.
It's a very similar technology. So what's in this specific HoloLens is, I think it's a structured light sensor. It's basically what it's doing. It's got a series of dots, which it's outputting, and then it's using those, seeing as how the dots reflect off and are absorbed by the material to figure out where it is. LiDAR works really well for longer distances. Now this thing has got spatial recognition to about 3 meters, something like that. You probably don't need that much, because if you're going faster than 3 meters wearing this thing, I'm not sure I'd do that. The reason why they do it on the cars and all the chips like that is because they're trying to look further out to kind of get that level of understanding about cars coming in or banks or things like that. Whereas for a human wearable device, you can deal with a little smaller of a scale, and lower power devices can work pretty well. It depends. It's all a trade. The different sensors, the LiDAR versus structured light versus this, it's all trading battery life versus distance versus accuracy versus. There's so many things which kind of go into what the right sensor choice is for the headset you need. And then, okay. So last thing, AR is the next wave of computing. It's not too far away. There's lots of money going into that area. The headsets are getting better all the time. I think there's so many complicated things going into them that it's almost as complicated. It's probably more complicated than doing the first mobile phone. So it's, whenever someone says, "I've got this brand new technology which will beat everybody," don't believe the hype. It's going to take a lot of money, a lot of time to actually make a usable, full device. AR and VR-enabled stuff will have plenty of new ways to interact with 3D data sets. How you're doing all this stuff together is going to provide a whole new way to interact with things. This stuff is hard. Putting everything in 3D is literally a whole other dimension compared to 2D. You've got to really kind of work that into all the development that you do. And we, of course, can help with that. So for all your AR projects, you know who to come to. That's it.